Let's answer the question, how do I combine, or how do you combine, like terms to simplify an expression? Here we've got the properties of addition. If you remember, you probably learned these in previous grades. You learned about the associative property of addition and the commutative property of addition. In this first example on page 189, we're going to talk about the commutative property of addition. Take a look at our situation here. It says Joey earned $A in the morning and $B in the afternoon. So here's our diagram. $A in the morning plus $B in the afternoon. That's A plus B to figure out his total number of dollars that he earned for the day. Ariana earned $B in the morning and $A in the afternoon. So it looks like she did the same thing. She just did her A work in the afternoon and her B work in the morning. But again, it's B plus A. These are equivalent expressions. A plus B is the same as B plus A. Remember, with addition, it doesn't matter the order. The commutative property of addition tells us that. 3 plus 2, well, that's the same as 2 plus 3. 7 plus 5, well, that's the same as 5 plus 7. So our commutative property of addition states, for any numbers A and B, A plus B is the same as B plus A. And you can see the example there. Besides the commutative property of addition, we have the associative property of addition. Here's our situation. Claire earned $A and another $B in the morning. So in the morning, she did something to earn $A, and then she did something to earn $B. And that's all in the morning. So this is grouped together because it's the morning. Then in the afternoon, she did something else, and she earned C. So the expression that we can use here is A plus B, which is grouped together because that's her morning work, plus C, which is what she did in the afternoon, to get her total dollars of A plus B plus C. Mateo, on the other hand, he earned $A in the morning, and then in the afternoon he earned his B and then C. So B and C are grouped together here because it represents the afternoon. But either way, it's still A plus B plus C. What we're trying to show you is the bars are still the same length. These expressions are equivalent. The associative property tells us that for any numbers A, B, and C, the sum of A and B plus C is the same as A plus the sum of B and C. Take a look at these examples here. 3 plus 4 gives you 7, 7 plus 1 gives you 8. Over here, if you do parentheses, 4 plus 1 gives you 5, 3 plus 5, well, that still gives you 8. So you can see the associative property of addition states that it doesn't matter how you group your addends. It's all about grouping. It's all about where those parentheses are. Except it really doesn't matter. It does not matter how they're grouped, how those numbers that you're adding are grouped. You're still going to get the same answer. Now we're going to apply that idea with algebraic expressions. It says on page 190, model each expression with algebra tiles. Then rearrange the tiles to model an equivalent expression with fewer terms. Write the new expressions. Make quick drawings to record your work. So let's see, the model of our original expression, remember the long algebra tiles represent the x's, and the small ones, the little squares, represent the constants, the numbers that we know. So I see 6, 1, 2, 3, 4, 5, 6, plus 2 x's, 1, 2 x's, plus another 1, plus an x. So that's the model of the original expression. What I'm going to do is I'm going to rearrange them so that all of the numbers are together and all of the x's are together. So I'm going to start with the x's. Here's the 2 x's right here. And then here's our other x right here. And then I'm going to put those constants together. So I'm going to put 6 here, 1, 2, 3, 4, 5, 6, plus that other 1. Now I have 7 of them. That means I have a new expression that I can rewrite so it's a little bit smaller. We've combined our terms. We combined the ones that we can put together. We put our x's together to get 3x. and we put our constants together to get 7. Our new equivalent expression is 3x plus 7. What we've just done is we have simplified our algebraic expression. All we did was we made it a little bit smaller by combining like terms. Like terms are terms with the same variables raised to the same power. Number terms are also considered like terms, even though they do not have variables. So take a look at this expression here. We have 6 plus 2x plus x to the second power plus 1 plus x. It says 6 and 1 are like terms, and I would agree. This 6 and this 1 are terms that we can put together. We could add them up to get 7. 2x and x are like terms. I agree that this 2x and this x over here, we can put those together and they would become 3x's. The thing that I can't put with anything else is this x to the second power. Remember, like terms are terms with the same variables raised to the same power. They have to be raised to the same power. Technically, this is 2x to the first power. This is x to the first power. They are raised to the same power. If there's no power there, you assume it's to the power of 1. But this one is raised to the power of 2, so we can't put that with any others. You can simplify an expression, that is, make it shorter and simpler, by combining like terms. So if I put the 6 and the 1 together, I get 7. If I put the 2 x's and the other x together, I have 3 x's. And x to the second power, I'm just going to have to leave it the way it is. There's my new simplified expression, 7 plus 3x plus x to the second power. Let's take a look at a few other possible like terms. I'm going to list some, and let's figure out if they're like terms or not. What if I gave you 5x plus 2x? Are they like terms? Yes, they are. 5x plus 2x gives you 7x's if you were to put them together. How about 5x plus 5? Are those like terms? No, they're not, because this is 5x's, whereas this is just 5. How about if I have 2x to the second power plus 3x to the second power? Are those like terms? Yes, they are. 2x to the second power plus 3x to the second power now gives me 5x's to the second power. How about 4x to the third power plus 3x to the second power? Are those like terms? Nope, they're not. That's because you have different powers. They have to be raised to the same power in order for them to be like terms. Let's do a little more practice. Let's look at some of the examples. This is workbook page 191. Our example, simplify 2a plus 3 plus a plus 4 by using a diagram. So this one has a diagram in it. And here's the expression. Here's your 2a's, here's your 3, here's your other a, here's your 4. And what we're going to do is we're going to rearrange them so that the a pieces are combined and the number pieces are combined. So instead of having 2 a's here and another a there, now we have 3 a's together. And instead of having a 3 here and a 4 over there, we can put the 3 and the 4 together. So now I have a total of 3 a's plus 7. That would look the same over here without a diagram. You can see here's the original expression, 2a plus 3 plus a plus 4. And what we can do is we can change the order. Our commutative property states, our commutative property of addition states that you can rearrange the order of your add-ins. It does not matter how you order them. So I think I'm going to flip-flop the 3 and the a. And now it looks like this. 2a plus 3 plus 4. Notice the a's are together now, and the constants, the 3 and the 4, are together now. And I can even put parentheses in there, because the associative property states I can group them different ways. I'm going to group the 2a plus the a together to get 3 a's. I'm going to group the 3 and the 4 together to get 7. Same thing, just without the diagram. So let's do some together. Let's look at number 5. We have 3x plus 4 plus 2x plus 1. Do you see any terms that you can put together? Any like terms? Remember, they must have the same variable and be raised to the same power. Or maybe they're just numbers without a variable. I see 3x and 2x. Those are like terms. I can put 3x's, 1, 2, 3x's, and combine them with the 2x's to get a total of 5x's. And the 4 and the 1, the numbers without the variables, the constants, here's 4 plus 1 more. Now I have 5x plus 5. Look over at number 6. D plus 2e plus 3 plus e plus 2 plus 3d. Whew, that's a big one. Let's see, I see a d here, 1d, and then I see a couple other d's over here, 3 of them. I can put my d's together. D plus 3 more d's gives me 4 d's. Notice I didn't put the d's with the e's. I'm keeping the e's separate. Like terms have to have the same variable in order for them to be alike. I can also put the e's together now. 2 e's plus another e, that gives me 3 e's. And finally, I've got my constants over here. I've got my numbers without variables. 3 plus 2 gives me 5. So my new expression becomes, or my simplified expression becomes, 4d plus 3e plus 5. So here are the takeaways. First, you have the definitions for the commutative property of addition and the associative property of addition. Remember, the commutative property states that it doesn't matter, how you order your addends. You're going to get the same answer no matter which way. And the associative property says it doesn't matter how you group your addends. Keep those in mind. I will probably ask you about those properties again. I also have the definition of like terms and what it means to simplify an algebraic expression, and here's an example. 6 plus 2x plus 1 plus x becomes, well, I might group the 2x and the x together and the 6 and the 1 together. 2x plus x is 3x's, 6 plus 1 is 7, and now I have 3x plus 7. You can simplify an algebraic expression by adding, sometimes even subtracting like terms. And remember, like terms have to be variables with like variables and numbers with numbers. So the x's could be together, the numbers could be together.